The new digital economy is rewriting the rules of businesses. Data-related activities are a central feature of the production process and a key aspect of economic activity. Novel digital products and services from multiple vendors are connected together to create, process, share, and distribute data in a digital continuum, blurring the frontiers between application domains and breaking the current silos of information. Today, most business processes follow a fully digital workflow. Thanks to the introduction of new architectures and patterns, the ICT industry is bringing more agility in the creation and management of new products and digital services that can be easily combined together to create more complex business chains. From a technical perspective, a digital workflow often consists in chaining multiple components in different domains and not necessarily with a strictly linear pattern. For instance, an industrial supply chain that encompasses manufacturing, transportation, and assembly may be designed to support just-in-time models and tight scheduling of all industrial and handling processes, ensuring regularity of supply and avoiding the need for large storage of components and products. Future services will be created with unprecedented degrees of freedom in their dimensions, digital infrastructures, software technologies, and data. Convergence among existing software paradigms, such as cloud computing, software-defined networking, and the Internet of Things is expected to this purpose, leveraging autonomicity and dynamic composition through service-oriented and everything-as-a-service models applied to cyber-physical systems. The process of creating digital products has already started moving from the delivery of static, closed, and monolithic software to service chaining and configuration, by connecting physical and virtual components in the enterprise, the cloud, and the Internet of Things. The growing complexity and the multi-domain nature make these systems ever more vulnerable to security breaches, due to human errors in design, implementation, configuration, and management. The first security concerns is that relying on individuals' ability when critical infrastructures and large chains are involved. The second security concern is the trustworthiness and reliability of the overall end-to-end service due to the amount of small devices from different players composed together in a business relationships. Third security concern is represented by the fully automated environments leading to complex dynamics and dispersion of data among digital objects, infrastructures, unknown or hardly trackable topologies. Guard improves awareness in heterogeneous digital services chains by embedding security capabilities in different layers of the business processes and providing a framework for collection, analysis, and detection. Most cybersecurity appliances have been traditionally designed to protect the physical infrastructure, not the services implemented on top of it. Looking at the ever more agility and adaptability to the evolving context at both the infrastructure and service layer, Guard chases a service-centric framework, with security capabilities embedded into each digital component, but orchestrated by a common security manager that logically centralizes the detection processes. This approach addresses conflicting needs of efficiency, effectiveness, and trustworthiness. The two main dimensions in a business chain, namely services and data, are directly reflected in the same number of security aspects: service integrity and data sovereignty. When connecting to an external service, the matter is not only if we trust its provider, but also how to detect attacks on the component and avoid their propagation along the chain. The main challenges in this context are to increase the information base for analysis and detection, while preserving privacy; to improve the detection capability by data correlation between domains and sources; to verify reliability and dependability by formal methods that take into account configuration and trust properties of the whole chain; to increase awareness by better propagation of knowledge to the humans in the loop. The vision of Guard is a multi-layer framework that distills trust, privacy, and security properties from a large set of data, providing tailored messages to different stakeholders. The unique characteristics of Guard will be programmability, which means that type, granularity and amount of data to be collected will be tuned according to the specific needs. Guard leverages standardized APIs and interfaces to build an open cybersecurity framework. Just like an operating system exposes computational data and communication resources to applications via an API, future digital services will include APIs that expose security properties, including configurations, monitoring, inspection, and enforcement rules. GARD will demonstrate its technology through two challenging use cases. Smart mobility. One of the most promising application fields for the data-driven economy, where security and trustworthiness are relevant, not only for privacy and confidentiality issues, but because they have strong implications on safety. EHEALTH, where GARD privacy by design will enable patients to monitor, track, and control the position and propagation of their personal and sensitive data. GARD delivers an integrated and holistic approach to tackle security and privacy risks in complex, extended, and dynamically evolving systems, improving the visibility over digital services. Programmatic access to the security context improves the efficiency of the monitoring and inspection process, while the ability to track private and sensitive information in complex business chains increases the awareness of end users and their trust in digital processes. Finally, access to a broad security context from heterogeneous sources is expected to further improve the effectiveness of detection algorithms for multi-vector attacks and identification of new threats.